In the last video of section 12-4, we're going to walk through how to solve a system of equations using a matrix equation when we have three variables. So again, the very first thing we need to do is set up a matrix equation. So the coefficient matrix are the numbers in front of our variables. And here we have a 1, a 3, and a -1. In our second equation, we have a 1. The y is missing, so it's 0 and a 2. And in our last equation, the x is missing, so we have a 0, a 2, and a -1. And then our variable matrix is x, y, and z. And our constant matrix is 2, 8, and 1. And if you can remember back to section 12-3, when we found the inverse matrix of a 3 by 3, we found it by using an augmented matrix. So let's go ahead and find the inverse of our coefficient matrix. And remember, to find the inverse, we need to add to it the identity matrix for a 3 by 3 matrix. So we add the identity matrix, and then we go ahead and we draw a line over our diagonal, and we need to zero out all of these numbers right here. So the very first thing that we need to zero out is we always walk down this first column. We need to get rid of this 1. So how can we eliminate it by using the other numbers in this column? We could multiply this very first row by a -1 and add it to the second row. So let's go ahead and do that math down here, or we'll do it off to the side over here. -1, -3, +1, -1, 0, and 0. And we'll just go ahead and duplicate this second row. We'll add them. And we're going to replace the second row right here. So now we have a 1, 3, -1, 1, 0, 0. We have a 0, -3, 3, -1, 1, 0. And then our bottom row. And as you can see, we were pretty good. We only have one more thing left to eliminate. And that is this 2 down here. Our first column is clear of numbers. We have a 2 down here. How can we use this number right here to eliminate our 2? What we'll do is we'll go ahead and multiply this middle row by a +2 and this bottom row by a -3. And if we multiply the middle row by a 2, we get 0, -6, 6, -2, 2, and 0. And our bottom row by a -3, 0. Ooh, let's change that to a +3. 0, 6, -3, 0, 0, 3. Now those 6's cancel out, and we get a 0, a 0, a 3, a -2, a 2, and a 3. So let's go ahead and write our new matrix with our new row in it. And we're replacing our bottom row because that's the row that we needed to eliminate a number from. All right. So now if we take a look at our diagonal, you can see all of the numbers underneath are 0, but we still have 3 numbers up here that we need to eliminate. So we're going to go ahead and use this 3 to eliminate this number. So that means we're going to have to multiply. Let's multiply our middle row by a -1. And when we do that, we get a 0, a 3, a -3, a 1, a -1, and a 0. We're going to add to it this bottom row down here. And when we do that, we get a 0, a 3, a 0, a -1, a 1, and a 3. So we're going to go ahead and replace our middle row with our new row. All right, so we're looking pretty good so far. Here's our diagonal. We've cleared out one of the numbers above. Let's go ahead and clear this out. In order to get rid of this, we need to use another number in this row. So we'll have to multiply this top row by a 3 and add to this top row this bottom row. So when we multiply the top row by a 3, we get a 3, a 9, a -3, a 3, a 0, and a 0. And the bottom row is a 0, 0, 3, -2, 2, and 3. And so when we add them together, we get this. And we're going to replace, since we wanted to zero out this guy, we're going to replace our top row with our new line right over here. We got a 3, a 9, a 0, a 1, a 2, a 3, a 0, 3, 0, -1, 1, 3, 0, 0, 3, -2, 2, and 3. Now it looks like we may only have one more item to get rid of. Okay, so far we have all zeros underneath, 2 zeros here. We only have to get rid of this. So I'd recommend multiplying our middle row by a -3. And that will get rid of that 9 for us. So if we write, this is the top row here. So let's just multiply this middle row by a -3. We get a 0, a -9, a 0, a +3, a -3, and a -9. When we add, we get this line. And let's go ahead and replace that top row with it, since that's the number we were trying to get rid of. All right, we have one last step. We need to divide each one of these rows by a 3. So that we put this, we end up with the identity matrix on the left-hand side of this matrix. When we divide everything by a 3, we get the matrix 1, 0, 0, 4/3, -1/3, and a -2. We get 0, 1, 0, -1/3, 1/3, and a 1. And then last, we get a 0, 0, 1, -2/3, 2/3, and a 1. The matrix on the right, this matrix right here, is our identity matrix. So let's go ahead and copy it up here so we can use it. Because I'm going to have to erase some of this writing on here. So there's our inverse matrix. Let's go ahead and get rid of some of this so that we can finish our problem up. Okay, so how will we use our identity matrix or our inverse matrix? How will we use this? We're going to multiply both sides of our equation by our inverse matrix. So we'll multiply the left side of the equation and the right side of the equation, which makes this matrix here go away. So I'm going to just write X, Y, and Z so I don't have to rewrite that matrix. But now I'm going to have to rewrite it over here. so that I can multiply it out by my constant matrix, 2, 8, and a 1. So let's lay 2, 8, and a 1 on top. And when I do that, 2 times 4 is 8/3. 8 times -1 is -8/3. And when I multiply that, I get a -2. Well, that's an easy answer, right? Already. 8/3 minus 8/3 is 0, minus 2 is just a -2. Now let's go ahead and do the same here. I get a -2/3. 8 times 1/3 is 8/3. 1 times 1 is 1. We add all these together. -2 plus 8 is 6/3 is 2 plus 1 is 3. Then I multiply this bottom row, I get a -4/3. 8 times 2/3 is a positive 16/3. And 1 times 1 is a 1. And we add all that up. 16 minus 4 is 12. 12 divided by 3 is 4 plus 1 is 5. There is the solution to my 3 by 3 matrix. And we can test it out. Let's plug it into our equation up here. All three of those equations. -2 plus 3 times 3 minus 5. And what does that equal? 3 times 3 is 9. Minus 2 is 7. Minus 5 is 2. And that checks out. How about the middle equation? -2 plus 2 times 5. That's 10. Minus 2 is 8. That one checks out. And let's test the last one. 2 times 3 minus 5 equals 2 times 3 is 6 minus 5 is 1. And that checks out. Our x, y, and z ordered pair is -2, 3, and 5.